Okay, so my topic was about sharks and all right, this is my table of contents, and what I'm going to be going over today is an introduction, a brief introduction about what sharks are, the shark's appearance in the popular culture and how it's affected our mind of what we think they are. Next slide is about their history and the fossil record. And then slide 4 is about their body structure. Next is their taxonomy, and then the classification. And then 7, their behavioral adaptations. 8, their evolution. 9, their diet, what they eat. And 10, their importance in our world. I'll start with the introduction. Okay, so sharks are a group of fish that have inhabited our planet for over millions of years. They can easily be called one of our oldest species known to still exist today. Ancient sharks have been in our oceans before many land vertebrae came into existence and before many plant species began to appear on the continents. They have survived and outlived many of their species during their time, developing different behaviors and anatomy that will only continue to improve. However, their appearance in the popular culture has given sharks the impression of fierce predators. But most sharks species are the complete opposite. Learning about sharks is a great experience and a step into protecting them from their extinction. All right, this one's about their appearance in the popular culture. Sharks have always been portrayed as merciless killing machines in the popular culture in many movies, such as Jaws. However, sharks are the complete opposite of their appearance. Attacks on humans are not intentional, as humans are not part of the shark diet. Most shark attacks on humans are usually mistakes in prey. Even so, encounters like this are very slim because research shows that the chance of being attacked by a shark are around 1 in 3.7 million. Sharks are docile creatures that have always been calm about humans. Shark-human contact is limited because most people consider them as meat-eating machines, but contact between the shark and humans are mostly not problematic. All right, this slide is about their history and their fossil record. In this picture is the 3 major eras of our history: the Paleozoic, Mesozoic, and Cenozoic. It is common knowledge that sharks have been around in this world for a very long time. They are even older than the first tree in this world. The earliest shark fossils date way back to over 450 million years ago. And this picture in the middle is a fossil record. And where sharks started coming around was about here in the Devonian period. To put how long they've been in our world into perspective, dinosaurs have showed up about 230 million years ago. Sharks have been existing for almost 2 times as long as dinosaurs. Also, the first human ancestors appeared about 7 million years ago, making sharks live almost 75 times as long as hominids. In addition to that, some shark species can live for very extended periods of time, such as the Greenland shark, which has a lifespan of about 300 to 500 years. In the history of this planet, there have been 5 mass extinctions, with sharks surviving 4 of them. The only organisms to have survived all 5 mass extinctions are the tardigrades. The 5 mass extinctions were the end Ordovician, the late Devonian, the end Permian, end Triassic, and the end Cretaceous. All these mass extinctions have killed off many species, but sharks have been able to survive 4 of them because of their behavioral adaptations and superior survivability. They even managed to survive during extreme times, such as when the ocean lost its oxygen. This happens when the oceans become warmer, and the warmer a liquid, the less gas it can hold. And even though sharks do not have lungs to breathe the oxygen, they still need the oxygen in the water to enter their bloodstream through their gills. An example of an event where the ocean lost all its oxygen was during the Cretaceous extinction, which was one of the most severe extinctions out of them all. During this extinction, a giant asteroid hit the Earth, and almost 80% of all species were wiped out. Sharks were able to survive this extinction. All shark data has been collected through something called a fossil record. The fossil record is a record that helps paleontologists find what fossils came before others following the law of superposition. This law states that any stratum that is younger will lie closer to the surface, while older stratum are deeper into the ground. In the fossil record, the fossils that are further on the bottom are older. This next slide is about their body structure. Sharks have a few physical features that other creatures do not have. One feature of a shark is their cartilaginous skeletons. Unlike most fish that have more typical bony skeletons, sharks have a skeleton that is made out of cartilage. Cartilage is very tough but also flexible tissue that functions as the main connective tissue in our body. About 80% of cartilage is water. Cartilage is also found in the human body in places such as the ear, nose, and joints. Sharks, rays, skates, and chimeras all have cartilaginous skeletons. Cartilage is less dense than bones. This allows sharks to move swiftly through the water without using as much energy as other fish. Next feature are the fins. All sharks have dorsal fins, second dorsal fins, pectoral fins, pelvic fins, anal fins, caudal fins, and the gill slits. The dorsal fin of a shark helps stabilize a shark while it is swimming. The second dorsal fin and the anal fin also have very similar functions. Both dorsal fins are located on the back of the shark. The pelvic fins are located on both sides of the shark in front of the anal fin. Pelvic fins help the shark balance while it's swimming, keep it level, and prevent it from rolling onto its side. Pectoral fins are located behind the gill slits and also on both sides of the shark. Pectoral fins are similar to airplane wings because they help provide lift for a shark while it is swimming. The caudal fins are situated in the back of the shark and on its tail. This fin is the main source of thrust while the shark is swimming, giving it its speed and power. Gill slits are a very important aspect of a shark because sharks will most likely not be able to live without them. Gill slits will filter food particles and they are used for gas exchange. Some sharks need to keep moving to keep the oxygen-rich water flowing through them. So if they stop, they will die. But some sharks can pass water through a respiratory system, so they're able to rest on the seafloor and breathe. Sharks also have an oily liver that makes up well over 20% of their weight. Regular bony fish have something called a swim bladder that is filled with air that helps them float. In sharks, however, their liver is filled with oil that helps them float, that helps them stay buoyant. They also store fat in their livers to help with long-distance travels. The third feature of a shark's body are the dermal denticles. The dermal denticles are the factor that gives the shark its stealthy predator and also another contributor to its speed. Dermal denticles functions to help reduce drag while a shark is swimming. This slide is about their taxonomy. Taxonomy is a field in research that involves naming and classifying all species. All organisms are grouped under a large category known as a kingdom. Sharks belong to the kingdom Animalia. Kingdoms are then divided into smaller groups that share the same characteristics known as phylum. Sharks belong to phylum Chordata. Next, classes include more familiar groups. Sharks belong to the class Chondrichthyes, which are all cartilaginous fish. Then the order is part of identification. Sharks belong to the order Elasmobranchi, which is divided into two superorders. After the superorders are the families, the genus, and species. The picture on the left is all the orders of Kingdom Animalia, and then the picture on the right is sharks, rays, and skates. Next slide is their classification. This picture is all families, all orders of sharks. And all these orders are the Hexanchiformes, which consist of 2 families and 6 species, the Squaliformes, which consist of 7 families, 126 species, Squantiformes, consisting of 1 family, 21 species, Cristioforiformes, 1 family, 8 species, Heterodontiformes, 1 family, 9 species, Erectolobiformes, consisting of 7 families, 44 species, Carcariniformes, 8 families, 280 species, and finally the Lamniformes, consisting of 7 families and 16 species. All animals have a taxonomy that classifies them. For example, the great white shark's taxonomy is the kingdom Animalia, phylum Chordata, class Chondrichthyes, order Lamniformes, family Lamnidae, and genus Carcharodon. Animal classification is very important to help because it helps us identify the name and group of all the animals on our planet. Based on similar DNA, RNA, or genetics, adaptations, and embryonic development, biologists can classify these animals. Next slide is about their behavior and adaptations. The shark's ability to survive and sustain life as an apex predator of the marine ecosystems for over 400 million years is a direct result of their behaviors and adaptations. Sharks have a range of behaviors that function to carry out necessary procedures such as survival and supremacy at the top of the marine food chain. Sharks combine physical adaptations such as their sharp teeth, heightened senses, forceful bodies, and behavioral techniques to help them catch their prey. Sharks are nocturnal animals hunting at nighttime. They are active and strong swimmers by night, but slow and sluggish in the day. During their hunts, sharks will bump or bite their prey in order to stun them, and then bring them down underwater or swim away and wait for them to die. Different species of sharks have different hunting strategies. For example, the great white shark will ambush their prey, while hammerheads and makos will directly chase after them. When a shark migrates, it will use a little feature called electroreception. Electroreception is a biological ability to perceive natural electrical stimuli. Electroreception is reserved almost exclusively for marine animals because water is more conductive than air. Adaptations are very important for every animal on our planet because it will help increase their biological fitness. One of the most important adaptations to sharks are the shapes of their bodies and fins. Their fins have special shapes and sizes that will help them move quickly in the water. Most shark bodies are in shape of torpedoes, which helps increase their swimming speed. This next slide is about tonic immobility. Tonic immobility isn't exactly only in sharks. They're also prevalent in the other organisms, even in humans. Tonic immobility is a reflex, I'll call it a temporary state of inactivity in the animal, which is very similar to hypnosis. This happens in many organisms, in our case, sharks. Tonic immobility is the natural state of paralysis in sharks. A main use of tonic immobility is for researchers to subdue the sharks when handling them. Tonic immobility is used in captivity and in the wild. To trigger tonic immobility, sharks have to be turned to their back or flipped on top of their snout, as you can see right here. This process is thought to disorient them, and during tonic immobility, a shark's muscle contractions will relax, and the breathing is more heavy and rhythmic. But some shark species are not as responsive as others, such as the great white shark. If a shark is undisturbed, they can stay in this paralyzed state for close to 15 minutes. This slide is about their evolution. This picture on the left is where they descended from. The one closest to the left are the earliest sharks, and they go up until the megalodon, which is in here the Cenozoic era. Sharks are believed to have descended from small leaf-shaped fish with no eyes, fins, or bones. These fish then evolved into the two main classes of modern fish that we know today: the chondrichthyes, which are the cartilaginous fish, and the osteichthyes, which are the bony fish, the more typical fish. It is hard to determine what sharks have existed in the past because of the cartilaginous skeletons. When a shark dies, their cartilaginous skeletons dissolve. But despite this, the fossil record has been able to determine about 3,000 species of sharks. The shark fossil records are very diverse, and this shows that some older species of sharks are very similar or almost identical to those today. An example of this is the Cladosalaki, which is the picture on the right here. This is one of the earliest sharks known to man, and you can see how their jaw is around in front of their mouth. And this is also in some other shark species, like the megamouth shark. Sharks have been always at the top of our marine food chain, and for some brief amount of times, they have been joined by other marine reptiles, such as the Mosasaurus or the Plesiosaurus. However, sharks are the only groups that have survived this long. All right, this slide is about their diet. All sharks are carnivorous, meaning that they will only eat other animals. The range of prey that are eaten by sharks are very broad, from snails to sea urchins, crabs, fish, rays, other smaller sharks, seals, and birds. Sometimes a shark will eat carrion like a whale carcass, but that doesn't usually happen because they usually go after live prey. Sharks eat relatively little compared to mammals, the reason for this is because sharks do not use their energy to regulate their body temperatures. Sharks eat about 1 to 10% of their full body weight per week in about 1 or 2 meals. Between every meal, sharks digest their food and will not eat again until their previous meal has been fully digested. The design of a shark tooth can help us determine what the shark ate. For example, flat teeth in a shark can say that they ate prey with hard shells, like the bullhead shark. Bullhead sharks have flat teeth, and their diet was barnacles, sea stars, crabs, and snails. Some sharks, like the whales and basking sharks, are filter feeders, filtering krill from the water using their gills as strainers. These sharks will swim through the water with their mouths wide open, and their prey will be caught in their gill extensions. Other species of sharks, such as the white shark, mako shark, and the hammerheads, will eat large fish, other sharks, and small marine mammals such as seals. All right. This last slide is about their importance in our world. As apex predators, sharks have played a very crucial role in our ecosystems by maintaining the organisms below them in the food chain. While hunting their prey, they keep other populations of marine animals in balance. As you can see here in the picture on the right, this is the food chain. It's kind of distorted because sharks are at the bottom, but sharks are at the top. Sharks help remove sick and weak prey from populations. This is very beneficial because it will prevent the spread of disease, and it'll increase biological fitness in the fish species. A removal of sharks from the marine ecosystems will lead to other species overpopulating and throwing the ecosystem out of balance. They can also help protect marine plants by preventing overgrazing of seagrass beds. An example of this are the tiger sharks in Hawaii, who hunt turtles, not tigers. If the sharks were not present, the turtle population would grow out of control and would lead to overgrazing. Starvation of other species, erosion on the earth floor, and a reduction in hiding spaces for fish are a direct result of this. In addition, sharks keep the natural carbon cycle in motion by feeding on deceased animals on the seafloor and sinking to the bottom when they die. Without sharks, the carbon cycle would be completely out of order. Sharks are also important in medical research for humans as well. Even though all living things get sick, diseases are less prevalent in sharks. Research on shark biology can help understand diseases in their marine environments. With sharks gone from our world, many marine ecosystems will start falling apart. A few examples are an out of control burst of algae and an extinction of small creatures such as scallops who rely on sharks to eat their predators. In the beginning, I mentioned the shark's bad appearance in our minds. After we learn about sharks, they are not the fierce predators that we think of them to be. Their existence is important to our planet and human economy through fish stocks and tourism. But despite their importance, sharks are being hunted, and many species of them are critically endangered or near extinction. Keeping sharks alive in our world is very important, and learning about them is a step into doing this. I'm done.